Let's take a look at the recursive exponential model. We have p sub 0 equals a, and p sub n equals p sub n minus 1 times r. Okay, so the first thing to recognize is that the p sub 0 equals a, is the first piece given, which makes these very easy to start. P sub 0 would be 1, or it would be 32, or it would be -4, etc. We have the beginning. Next thing to note is the r value is the coefficient of the p sub n minus 1 term. Now, although the recursive exponential model has the times r on the right, you'll notice that the coefficient is typically out in front, because that's usually where coefficients are. So the r value, 3 or 1/2 or -2, that is also easy to grab from the recursive definition. Now, how to find the next few values of this sequence, p sub 1 and p sub 2. There are multiple approaches. One approach relies on what you already know, and that's the explicit model. P sub n equals p sub 0 times 1 plus r to the nth. The problem with doing it this way is there's a surprise, and that is that the r here isn't the same value of r as here. The r here is in fact this entire piece, the multiplier. And so that makes this method confusing. I will show it in case this is the way that you want to do it. But basically, we would have 1 plus r equals 3. So plugging in p sub 0, 1, and then we get this whole thing is 3 to the n. This is just 3 to the n. And now if I want to find p sub 1, I plug in 1. 3 to the 1 is 3. If I wanted to find p sub 2, I'd plug in 2. 3 squared is 9. So that makes it a little bit more difficult, because you can't just say, oh, r equals 3 and plug 3 into this r, because those r's actually aren't the same. And that's a confusing factor for students. So because of that, let's discuss some other approaches. Well, first off, we have our formula approach. So for our next example, let's work out the formula approach. That would look like, to find p sub 1, I would need to plug in 1 in for n. And the formula would be p sub 1 equals p sub 0 times r. Now we know what p sub 0 is for this problem. It's 32. And r was 1/2. 1/2 of 32 is 16. We have p sub 1. To find p sub 2, well, we have to plug in 2 for n. And that would give us the formula p sub 2 equals p sub 2 minus 1. P sub 1 times r. Now we know what p sub 1 is because we just found it. It's 16. And r again is 1/2. Half of 16 is 8. Okay. To review, we could also find the explicit formula. And it would look like p sub n equals p sub 0, which was 32, times the r here is actually the entire 1 plus r. And so we could plug in 1 into that, or 2 into that, etc. Now there's a third approach, and that would be understanding the exponential model itself. Exponential models are multiplication or division models, repetitive multiplication. So knowing that we're starting at 1, this sequence is a times 3. 1 times 3 is 3. 3 times 3 is 9. This next sequence, starting at 32 is a divide by 2, or a multiply by 1/2. Dividing by 2, 32 divided by 2 is 16, or 1/2. 16 times 1/2 is 8. It's a halving sequence. So if you understand that, you could probably write down the next two of this one. You start at -4, and this is a times -2 sequence. -4 times -2 is positive 8. 8 times -2 is -16. Okay, now, before you go on, there's one last approach, and that is with the calculator technique using your answer button. So the way you get it started, and let's review this last one just as an example. Type in the first term, and then go to the recursive definition, and on the right side, type everything in but use the answer button as the p sub n minus 1. So this would be -2 times answer. Or you could just do -2 answer. When I hit enter, it's going to evaluate -2 times the answer, and the answer is what's previously in the calculator, in this case -4, and it should give me -2 times -4, which is 8. And then if I hit enter again, it will take 8 and times by -2 and get us -16. And keep hitting enter, and you will see the sequence evolve. So for the previous one, starting at 32, and then doing 1/2 times answer, 1/2 times answer, 32, 16, 8, 4, 2, 1, decimals, fractions, fractions, fractions. That is another approach, a calculator approach. Okay, so go ahead and pause the video and finish the rest of the examples and see what you get. Okay, R 10, then we'd have 3 and 30 and 300. R 1/10, starting at 50, then 5, then 0.5, which you could reduce to 1/2 if you'd rather. R is 1, 2.5, 2.5, 2.5. That's a constant sequence. It could be linear or exponential. It's just the next term equals the term before it. All right, I hope this helps.